Very good morning, students. So, in this part, this is the chapter Movements of Ocean Water Geography. And here, a student, in the previous video, I told you many more points related to tides, and I told you about the types of tides also, which was based on frequency. And I told you about the semi-diurnal tide, which have there is two high tide and two low tide in a day, is called semi-diurnal tide. So in the picture you can see one side is high tide and another side you can see low tide. Second one I told you diurnal tide, which is one high tide and one low tide in a day, is called semi-diurnal tide. So you can see here. Next is the mixed tide, which I told you about, that the tides having variation in height is called as mixed tide. So through the picture I just wanted to show you which type of the uh, variations you can see in the height. Somewhere you can see tidal rise, you can see, which has mentioned through the red color, and high low water tides you can see over the blue color. Okay, so this is called mixed tide. Next was which I told you on that day, types of tides, like based on position of earth, sun and moon. So here you can see this is in a straight line. Okay, which is very important. The spring is linear, that how you can remember, but it is not at 90 degree. Okay, next is a spring tide, when the sun, moon and earth are in straight line. Okay, so occurs twice a month. So this you can see through the picture. Nap tide, this type of tides occurs when the sun and moon comes right angle to each other. Okay, so this is the picture. In the last video I didn't show you the picture. And then we have advantage of tides: promotes water transportation, help for fishing, remove coastal waste into deep sea, and promotion of hydroelectricity, right? And apart from this, I told you about the perigean apogee, also perihelion and aphelion, right? Then we have two important terms you have to remember: ebb and flood. It also known as flow. Ebb means when you have the duration between high tide and low tide, but the water level is falling. So that's how you remember it. In the water level falls, we call it that is ebb. Between low tide to high tide, and when the water level keeps on rising, we call it as a flood, right? So, or a flow. So rise of water falls comes here, but ebb flood goes there. So that is how you can remember. It's a kind of crisscross variation. So falling is not related to flood or flow, it's related to ebb. So now you can see the falling patterns is seen in ebb, and rising pattern is seen in flood. Clear? Differences between ebb and flood. So these tides are indeed very important because they help in the navigator, sailors, fishermen to move cross. Again, when the boat have to enter the harbor that is written by the tides, the kind of sedimentation flowing in the desolation is that is need to be uh, done. Everything is governed by the tidal flow. Because of the tidal flow, you have tidal energy that is being generated. A major project has been going on closer to some of the projects are there, like Sundarban in India. So you can see, so these are the some advantages of tides, like promote water transportation through the tides. Okay, and then help of fishing, remove coastal waste into deep sea, and promotion of hydroelectricity. Okay, but some of the points are like regarding disadvantages of it. Some drawbacks also, like there: cause of destruction of boats and ship, and affects ship movement through this disturbing sea route, and formation of marshy land and destruction of deltas. Clear? Next is ocean currents. So students, now ocean currents, when we say ocean currents, that are two forces that affected. One is primary force and other is secondary force. Secondary forces simply influence the flow. So how the this things flow is influenced by the secondary flow. When we talk about the primary force, there are three things we take into account. Okay, so factors, there are some factors influencing ocean currents. So first is heating because of the solar energy, and second is wind and gravity. Okay, and fourth is Coriolis force. Okay, so but mainly actually there are three main things we take here: heating, gravity and Coriolis force. Clear? So types of oceans currents on the basis of depth: surface current and deep water current. Okay, so before this I just wanted to explain about the heating by solar energy. Heating cause is expansion of the water. Definitely the expansion is more where it would be more closer to the equator. So equator have more expansion of water, that would be seen as compared to a polar area. Therefore the height of water at equator is 8 centimeter more than the that is the pole, and because of this slope you would have the movement towards it. That pole that takes place as simple as that. Next is gravity. Okay, so in gravity, that is the reflection towards the right in the north hemisphere and left in the south hemisphere, which we have covered in a very separately class to understand that. Again the currents are the strongest at the surface. That interaction uh, with the air that takes place, and this strength governs the speed of the current. So more the strength of the current, you would have higher the speed that would be witnessed. Higher the speed, the stronger than the current, and this strongest currents therefore in towards the surface, and you go deeper in the ocean, the current speed would decrease and in intensity decrease. So vertical gradients affects the current, and that is very very important. Now warm water currents travels from equator to pole, and at the pole they replace the sinking water from the poles. You have the cold currents water that sink in the bottom larger and comes towards the equator where it rises. So this movement is what is known as thermohelian circulation, that is generated into the oceans. Now the types of ocean currents that can be, say, there can be surface currents which are only 10%, and there can be deep water currents which are 90%. Most of the ocean water based on the gravity and the intensity and density, you have the deep water currents that are seen. Based on the temperature, if we talk about the based on the temperature, so here student I have I'm showing you here types of ocean currents on the basis of depth, surface currents and deep water current. And on the basis of temperature, if we are talking on the basis of temperature, there can be cold, warm and ocean currents. Okay, warm current and cold current. Okay, so cold currents are currents that moves from a cold area. Okay, that moves from the cold area to a warm area. Usually is the most mid latitude closer to the equator. It is on the western sides. However, in the northern hemisphere, it is higher latitude in the western side. So vice versa, from warm currents which are originated from the equator or the warm areas and moves towards the colder area. So they are seen on the eastern side in the low latitude in contrast to what we have seen for the cold currents. And on the western side, in the higher latitude is northern hemisphere, and vice versa in the southern hemisphere. Now these currents, as we said, highly influenced by the winds. Its effects from the winds and the Coriolis force and the ocean's circulation in very good correspondence to the air circulation above it. So the surface water movements is very important to understand this. Now air circulation over the ocean. Okay, so I'll show you through the map also. So I just wanted to tell you um, about the latitude become anticyclonic, and this is very very important because the transportation of heat that is from one latitude to another. So with each latitude it would have the transfer of the heat that would take place, and this create geysers. Okay, have you heard about the geysers? So we have the eastern boundary is and the western boundary where you have the movements that takes place. So warm currents usually flow parallel to the east coast, mainly in the tropical areas, right? So here you can see on the map, like here we have major oceans of the world: Pacific Ocean, Atlantic Ocean, Indian Ocean, and Arctic Ocean. So major oceans currents of the world is here. You can see from the blue color it has shown here on the map is cold currents, and from the red color it has shown on the map warm currents. So here you can see, students, from which side to which direction it goes. So you can see the cold currents is moves to the if we talk about the Indian Ocean, you can see here how in which direction it moves. Clear? So warm currents usually flow parallel to the east coast, mainly in the tropical areas, subtropical areas, and this warm currents leads to a warm and rainy climate, usually on the western margins of the subtropical anticyclone season. We see, and whenever it has the mixture of warm and cold currents, you would have the most fertile fishing grounds that could be seen. Okay, so its effects on the human nature also, in human life also. Okay, so it's a very high growth of planktons also. You can see it can be seen if numerous planktons and numerous fishes you can see there, and these are the major fishing sites across the globe. So this map will help you to understand how the ocean currents, ocean currents, warm currents and cold currents flow areas the globe. Okay, so ocean currents of Pacific Ocean, you can see here ocean currents of Pacific Ocean. Warm currents are in North Equatorial Current, Kuroshio Current, Alaska Current, West Australian Current, South Equatorial Currents. These all currents are warm currents. And another side, Oyasio Current, California Current, West Wind Drift, Humboldt Current. These are cold currents in Pacific Ocean. So here you can see on this map. In Atlantic Ocean also I have seen. So I'll make another video on this topic, students. So till then, thank you so much.